1.1 homework help is limits with graphs. And let's take a look at number 1. Number 1 gives you a graph and it gives you a piecewise function. You're looking for the limit as x approaches 2 from the left. So coming in from the left side on your graph is on this side of your graph. As x approaches 2, so here's your x equals 2, you need to know what your y value is there. So your y value there is 1, 2, 3. And it doesn't have to be a colored in circle for it to work. Number 2, the limit as x approaches negative 2 from the right. So here's x equals negative 2. Coming in on the right side is on this side of the graph. There's x equals negative 2. The y coordinate there is negative 2. The limit as x approaches 0 overall. So coming in from the left, here's x equals 0. The y coordinate coming in from the left is 1. Coming in from the right, this is also approaching 0 from the right. It's 1. So if the left and right limit is the same, then that's your overall limit. The limit as x approaches 4. So here's x equals 4. And the left and the right side, it looks like I'm off a little bit, hit the same number. The y coordinate there is negative 4. Use a table or a graph to do this one. Let's go ahead and let's do a table since we haven't done one yet. So here's 1. And we don't really care what's going on. We can figure out what's going on at 1. And then let's pick something really close to 1 on the right side of it. And let's pick something really close to 1 on the left side of it. So let's plug in 0.99. So 4 times 0.99 is 3.96 minus 2 is 1.96, absolute value 1.96. Plug in 1. 4 times 1 is 4, minus 2 is 2. And then plug in 1.01. 4 times 1.01 is 4.04. Subtract 2 from that, you get 2.04. So coming in from the right side, it looks like you're approaching 2. Coming in from the left side, it looks like you're approaching 2. And if you plug in the exact number 1, it definitely looks like you hit the number 2. Graph, then find the limit. So first thing we have to do is graph y equals x squared minus 1. You might remember from college algebra, it's a parabola shifted down 1 unit. If you don't remember, let's make a basic t-chart, and let's plug in negative 0, negative 1, 0, and 1. If you plug in negative 1 squared is 1, minus 1 is 0. Plug in 0, 0 minus 1 is negative 1, and plug in 1, you get 0. So negative 1, 0, 0, negative 1, and 1, 0. You have a parabola looking something like this. And since our limit, one of our limits is at 2, let's go ahead and plug in 2. So if you plug in 2, you get 4 minus 1, which is 3. So 2, 3. So if you're looking at the limit as x approaches 2, here's x equals 2. The y coordinate when x equals 2 is 3. And if you look at the limit as x approaches negative 1, here's x equals negative 1. The y coordinate right there is 0. Graph. We're going to do a multiple choice graph. So let's do a t-chart again. Let's plug in negative 1 and let's plug in 1 and start to see what happens. If you plug in negative 1, you get negative 1 plus 2, which is 1. And if you plug in 1, you get 1 plus 2, which is 3. Negative 1, 1, and 1, 3. If you recall from college algebra, I could go back over here and get a common denominator. So 1 over x plus 2x over x, which is 1 plus 2x all over x. And you would recall that when your bottom equals 0, you have a vertical asymptote. So right here, there is a vertical asymptote being formed at y equals 0. And then you can also recall from college algebra your horizontal asymptotes. If the degree of the top, which is 1, equals the degree of the bottom, which is 1, then your horizontal asymptote occurs at the leading coefficient of the numerator, which is 2, over the leading coefficient of the denominator, which is 1. So you have a horizontal asymptote at 2. I think this helps you see that your graph is then going to approach both of these asymptotes. So as x approaches infinity, as we get way out here to positive infinity, look at where this asymptote's occurring, because it's going to keep getting closer and closer to it. So your y-coordinate there is 2. And then as x approaches 0, here's x equals 0. And from the left side, it's going down forever. From the right side, it's going up forever. So since they're different, your limit does not exist. All right, let's do this one without a graph. So the limit as x approaches 8 from the left. So if we're looking from the left, you're looking at the less than is left. So we're going to plug in 8 to the top function. So we get 8 plus 5, which is 13. If you're looking at the limit as x approaches 8 from the right, greater than is right. So we're going to plug in 8 right here. You get 7 times 8 minus 43. So you get 56 minus 43, which is 13. And then if your left limit equals your right limit, then your overall limit is that number. Number 9. All this is saying is let's take the limit as x approaches c. c is given, so we're looking for 4 from the right. And remember, the right is greater. So you're going to plug 4 into the bottom function. You get 4 over 4 plus 1. 1 plus 1 is 2. Down here, so c is 4. You're looking at 4 from the left. Left is less, so it's 5 minus x. c is 4. You get 1. And then let's take the limit overall as x approaches c, which is 4. And since your left limit was 1 and your right limit was 2, they're different, so your limit does not exist. Multiple choice. Pick out the graph of the piecewise. So on the first part, x is less than 0. Let's pick 0, negative 1, negative 2. If you plug in 0, you get 0, negative 1, negative 2. At 0, 0, since there's no line underneath, you're going to, let me double check it, make sure there's no line. Yeah, there's no line underneath. So since there's no line underneath, we're going to put an open circle at 0, 0. And then all the other ones are going to be closed. So negative 1, negative 1, negative 2, negative 2. So here is your graph. And then for the right side, we're going to plug in 0. It's going to get an open circle. Plug in 1, plug in 2 because we're getting bigger. You get 0, 1, and 4. So at 0, 0, it gets an open circle. 1, 1 is colored in, and 2, 4. 2, 3, 4. And this side is going to kind of form a curve because it is a parabola on that end. So find the limit as x approaches 0. Looking at the graph of it, coming in from the left side, your y-coordinate 0. Right side, your y-coordinate 0. Even though there's not a colored in dot there, your overall limit is 0.